Good morning, everybody. It's Mr. Marquardt here again. Today it is Wednesday, so hump day, right in the middle of the week. We are talking about 1.2.2 today, cube root and absolute value functions. A couple announcements before we get started on that, though. Again, reminder, Friday we have our first formative quiz of the semester on function machines. So make sure we are working through the homework because there's a lot of good problems on function machines in there. So if you have any questions, please come to office hours on how to do that. So plugging in values into functions. Hopefully we are getting more comfortable with that as we start the school year here. But first quiz is in 2 days. 2 days on function machines. So make sure we take a look at that as we go through the week here. Homework collection will also be Friday. Fast bridge test will be tomorrow. So make sure you are in your live class so we can take that. And again, if you are struggling with anything or just confused, want to stop in and say hi, please come into office hours for help. So we are all happy to help you guys out, all 5 of us on the Algebra 1 team. So today what we're going to be doing is check the answers for the homework. You can pause the video and take a look when we get there. We're going to work through a couple problems in class today, and I'm going to leave a few for you to do as well as we go through this lesson today. So make sure we have our white packets out, our yellow homework packets, and then our yellow toolkits because we will need those at the end of class as well. Pause here to check your answers for the homework. Perfect. We're going to keep moving. So 1.2.2, cube root and absolute value functions. So you have drawn graphs of different families of functions like lines, quadratic functions, and square roots. As a class, you saw an inverse proportional graph in the hot tub design problem and an exponential graph in the flu outbreak problem. Today we are going to explore the graphs of 2 additional functions. So we have cube roots and we have absolute value. So we'll talk about those more in just a couple minutes here. So as a reminder, a linear function, straight line, what we have in red right here. So inverse variation kind of tracks data between those two axes right there, and then the exponential function just grows and grows and grows at a really steep rate as we go further to the right. So hopefully we have that on our toolkit. If not, this would be a great time to pause the video and make sure we have those things on our Chapter 1 toolkits. All right, so 143 cube roots. So the solution of b to the b cubed, so that's what that little 3 means right here. So b to the third, or b cubed, is equal to 8, is called the cube root of 8. That's what the solution to this problem is. The idea of a cube root is similar to that of a square root, except for the cube root of 8 must be cubed, meaning that it's multiplied by itself 3 times to become 8. So one way to write the cube root of 8 is using the notation right here that looks like the square root symbol, but there's this little 3 right here. Over the top of that, that tells us that we are taking the cube root. So the cube root, if we take the cube root of 8, this would be equal to 2, because 2 times 2 times 2 gets us back to 8. All right, so how would we write that for this right here, this little equation right here? So if we want to try to find what t is equal to, knowing that t cubed is equal to 30, but whatever we have to do to one side, we have to do to the other to keep things happy in algebra. So we have to take the cube root. So I'm going to rewrite this real quick. We have to take the cube root of both sides. So again, it looks like the square root function. If we don't put a number there, we're going to assume we're trying to take the square root. So we have to remember to put that little 3 outside of that. Then we're doing the same thing on both sides. So when we do this, the cube root and the cube kind of cancel, and we're left with our t is equal to the cube root of 30. Oh, gotta write 30 in here. Cube root of 30. If we put that into our calculator, hopefully everybody has a calculator that looks something like this. So when we're doing this in our calculator, we need to hit 3 first, and then we are going to hit second, and then the caret button. The little button that looks like this on our scientific calculator, that gets us to our cube root, so 3. Then we have to do seconds. Then we hit caret, and then we put in 30. So when we do that in our calculator, we should get 3.11 is the cube root of 30. So if you're having troubles plugging that into your calculator, please come talk to us in office hours so we can help get that squared away for you. All right, B, if we have the square root squared, that cancels, like those things cancel each other out. So here we're left with 64. This one, square root and the square cancels, so that's with 19. In part C, I think we should be able to extend this logic to cube roots as well. So if we have a cube root cubed, these are going to cancel, so we are just left with 30. In part D, we did up here already, plugging that into our calculators. All right, now we're looking at 144. Lydia wants to know what the graph of the cube root function is going to look like. So the cube root of x. So we need to find some values that we can plug in for x that are going to come out with nice looking y values for us. So we can plot our graph a little bit easier. So I'm just going to pick some random cube numbers that we know off the top of our heads here that we can use to find a nice graph for ourselves. So I'm going to pick some x values like negative 125. We're going to do like negative 64, negative 27. What is that? Negative 8, negative 1, 0, 1, 8, 27, 27, 64, and then we're going to do 125 all the way over here. So those are going to be our perfect cubes between negative 150 and 150, like it says in our directions right here. So if we plug these values into, again, our function, which is y equals the cube root of x, if we plug in negative 8 into the cube root, unlike the square root function, we can take the cube root of a negative number. So if we plug in, let's say, negative 8 here, we should get a negative 2 back. A negative 2 back. And that works because if we write this out here, negative 2 times negative 2 times negative 2, if we have an odd number of negative things multiplying together, our answer will be negative. So negative 2 times negative 2 times negative 2 is 8, or negative 8, sorry. So for all of these different things we go through, these should all be negative on the left-hand side of our table here, because we need 3 negative things to multiply together to get a negative cube root like this. So for here we are going to have negative 1, negative 3, negative 4, and negative 5. The same thing works. In the middle we're just going to have 0, because 0 times 0 times 0 is still going to be 0. If we have a 1 over here, these are going to be positive. If we do 8, we talked about that one already a little bit before, but the cube root of a positive 8 is just going to be equal to 2, because 2 times 2 times 2, again, is 8. So that is 2, we have 3, 4, and then 5. If you have any questions where I'm getting these numbers from, please come to office hours and let me know. We're more than happy to help you figure that out. All right, so let's take a look at what this looks like on a graph. Again, we have our questions here from class yesterday. How do we describe a graph? So I'm going to graph this equation for you, but I want everybody to answer those questions on your own and check it against the filled in notes here. So we're going to assume that every unit on the graph is 10 units instead of just 1. So this is 10 units per square. So now we have, first one you can really point is 0, 0. We're going to have negative 1, 1, which is going to be right next to it. Let's graph instead, let's try like negative 27, negative 3. So negative 27 will put us right about here, down 3 is something like that. Negative 64, down 4. And negative 125 is going to put us over off the graph a little bit. And then we're going to be able to do the same thing on the other side here. So over 27, 3, over 64, 4, a little bit off the graph. So basically what this graph is going to look like, it's hard to tell because we're kind of zoomed out here. is something like this. So if we were to zoom in, it would look, let's change colors. We're going to zoom in and focus on this part of the graph. So what this graph is going to look like is something like that for our cube root function. Cube root function. So describe what that looks like in our picture here. Check your notes against the filled in notes that are going to be on us learning later today. Otherwise, we're going to keep moving. So now we're going to go to our absolute value functions. Let's pick some values here so that we can put in our t-chart, and then we're going to graph this one as well. So let's go like -2, -1, 0, 1, and 2. So hopefully you remember from class from last week that anytime we put a number into an absolute value, we always get a positive number out because it's the distance from 0 on a number line for whatever number we put in there. So for -2, we should get 2, -1, we'll get 1, 0, 1, and 2. And now we got to plot these points. So now we're back to normal scale on our graphs. We have -2, 2, -1, 1, 0, 0, 1, 1, and then 2, 2. So if we graph this, we get that graph that looks kind of like a V. Everybody's seen Mighty Ducks? It's like the flying V for a absolute value function there. Again, what I want you to do is go back, look at the pictures from this, or the questions from this graph over here, answer these questions again, check them against the filled in notes that we'll put on It's Learning later today. So as we look at this function, also take a look at part B. Are there any values of x that can't be used in our absolute value graph up above here? So take a look at that question as well. Try your best to answer it and check it against those filled in notes that we'll put on It's Learning. So if you have any questions, let us know. Lastly but not least, 146. This one's going to be kind of a challenge problem for you guys. So this 2 and this -1 are going to help move or change that function just a little bit around the graph. So again, if our parent function is y equals the absolute value of x, try to describe how these two numbers are going to influence our graph and help change it just a little bit. So again, what I want you to do for this one's going to be on your own. Plot some points into our function here. Let's just say, let's go -4, -3, -2, -1, 0, all the way through 4. Plug those in. It's good practice to plug in values and get an output. Get your y values and find what this graph is. Again, check it against those filled in notes on It's Learning when we get those posted later today. All right, then again, answer those same describer questions so we get used to answering questions in as much detail as we possibly can. So for tomorrow, our homework is 1.2.2. Do not do section 1.2.1b. We'll do that and talk about that tomorrow in class. So for tonight, it's problems 147 through 151. So take a look at those tonight. And then last but not least, we've got our toolkit for today. So again, we talked about the cube root. So for this function again, we can see it a little bit nicer on this picture here. It's going to look something like that for the shape of that graph. We know that, as my lights go out on me here, that the cube root of 8 is 2, because 2 must be cubed to get to 8. So again, what this means is that 2 times 2 times 2 is equal to 8. All right, that's all we got for you guys today. So if you have any questions, please feel free to stop in the office hour, shoot us an email, whatever you got for us. We're always happy to help out. So hope you have a great Wednesday, and we'll see you all in live class tomorrow.